Welcome to today's episode on this web channel. If you have not subscribed to the channel, kindly do so for more episodes to come. Remember, we are still on the same topic, how to determine the nature of roots of a quadratic equation. And in today's lesson, we want to look at its application in solving questions. Before we start looking at these two examples on the board, let me give you a quick reminder on what we did under the nature of root of a quadratic equation in our previous lesson. So in our previous lesson, we said that to determine the nature of roots of a quadratic equation, we make use of what we call the discriminant. Now the discriminant is giving us so this is called the discriminant, and it helps us to determine the nature of roots of a quadratic equation. These discriminants can be obtained from the quadratic formula. It is the expression under the radical sign. So what does this discriminant say? Now when this discriminant is greater than 0, then we are going to get real and then distinct or different roots. When the discriminant is equal to 0, then we are going to get real and then equal or repeated roots. That is when the discriminant is equal to 0. Now, when the discriminant is less than 0, or when the discriminant is negative, we are going to get a complex root or imaginary root. Let me repeat it again. When the discriminant is positive, then we are going to get a real number and then different or distinct roots. When the discriminant is 0 or is equal to 0, then we are going to get what? Real, equal, or repeated roots. And then lastly, when the discriminant is negative or less than 0, then we are going to get what? An imaginary or complex root. So this is what we said in our previous lesson. Let's look at how we can apply this concept to solve these two questions on the board. So we want to find the value of k for which the quadratic equation, which is this one, has equal roots. And we have just learned that when the quadratic equation has equal or repeated roots, then the discriminant is equal to 0. So we know that when the quadratic equation has equal roots, then the discriminant is equal to 0. So once we know this, we are going to find our a, our b, and c from this quadratic equation. We substitute it into this, and then we solve for the value of k as easy as a, b, c, d. So from this quadratic equation, Ra is equal to what? The coefficient of x squared, which is k. Rb is the coefficient of x, which is what? 12. And then Rc is the constant, which is 9. So we are going to substitute this into the discriminant to solve for the value of k. So we have b squared, our b is 12. So we have 12 all squared minus 4, our a is k. So we have times k. And then our c is 9. So we have times 9. And all of this is equal to what? 0. This will give us 144 minus this will give us 36k, and all of this is equal to what? 0. We are looking for k, so we have our 144 is equal to what? 36k. What do? We divide both sides by 36, both sides by 36. This will cancel this, so we have our k is equal to what? So the value of k, which enable this quadratic equation to have equal roots, is what? K is equal to 4. Let's look at this example. We want to find the value of k for which the quadratic equation, which is this one, has equal roots. So if this quadratic equation has equal roots, then it means that the discriminant is equal to what? 0. Good. So we have to identify our a, our b, and c from the quadratic equation. So from here, we can say that our a is the coefficient of x squared, which is 1. Our b is the coefficient of x, which is what? Minus 2k. And then our c is the constant, which is what? K plus 2. Now, once you have this, we substitute it into the discriminant. B squared is minus 2k all squared minus 4. Our a is 1. And then our k is, our constant, sorry, is k plus what? 2. And all of this is equal to 0. This is going to give us 4k squared minus, we have 4. This is going to give us k plus what? 2. All is equal to 0. We still have our k squared minus, let's expand the bracket. 4 times k will give us 4k. Then we have minus 4 times 2 give us what? 8 is equal to what? 0. Now, once you get this, you realize that we are having what? A quadratic equation. And you can use any of the methods that we have discussed in our previous lesson to find for the value of k. We can use the completing of squares. You can use the quadratic formula. You can use the factorization approach. And you can even use the calculator to find the value for k. So when you use any of these methods, you have your k to be equal to -1 or k is equal to 2. So the value of k, which enables this quadratic equation to have equal roots, is either k is equal to -1 or k is equal to what? +2. As easy as that. This brings us to the end of today's lesson. See you tomorrow. Bye bye.